Welcome back to this live lesson series on quadratics. Specifically today we'll be looking at how do we solve a quadratic from factorising. Now the prior knowledge needed to access this lesson will be these two lessons here, which you can go back and watch, Factorising Quadratics 1 and Factorising Quadratics 2. It's very important that you watch those lessons because I'll be talking about aspects of those lessons and not going into detail about them. I'll just be assuming that you know them. So make sure you have seen those lessons because that's going to let you access what I'm about to do today. Okay, so that takes us into solving quadratics from factorising. Now there's a few things that we should talk about before we look at how do we solve from factorising, which is the basics of quadratics and their graphs and how they look. Now you should know that a quadratic graph is a smooth curve that has symmetry. Okay, and they can be anywhere on a graph. You can see this one. This is the line, or the curve, sorry, y equals x squared, which is a smooth curve that sits on the origin, whereas the one to the right is the curve y equals x squared plus 4x plus 3. And that, as you can see, sits slightly different and actually cuts the x-axis here. Now, what we say is, and if you've seen those two lessons prior, you would know this ax squared plus bx plus c is the general form for a quadratic. When we solve ax squared plus bx plus c equal to 0, what we're actually finding is where the curve cuts the x-axis. And as you can see here, we are finding these 2 points right here. And the other two words that they use for these in exams and in maths generally is solutions or roots. So the solutions or roots for the curve y equals x squared plus 4x plus 3 would be minus 3 and minus 1, because that is where the curve cuts the x-axis. And if we look at the generic y equals x squared curve, you can see that it doesn't actually cut the x-axis. It sits on the point 0. So the solutions to this one would be x equals 0. And the solutions to this one here would be x equals minus 3 and x equals minus 1. So it's really, really important that we understand, and I've put it in a remember me box, that when we solve a quadratic, remember, ax squared plus bx, these a, b's and c's are just integers that can be any number. We are finding where the curve cuts the x-axis, which is actually when y equals 0, so when this equals 0 here. Another interesting fact that we could point out, which I'll finish on before we get into the method of solving, is plus c. Okay, this bit on the end, plus c, we have seen in our straight lines lessons that the plus c, y equals mx plus c, we know that the c is the y-intercept. And what's interesting here is, what is the plus c in this equation? It's plus 3. Okay, so plus 3 is where it cuts the y-axis. So it is also the y-intercept, which is a very interesting point, that this plus c is the same as y equals mx plus c. And that is really, really interesting to point, which will go in more depth when we look at the actual curves, okay, when we do a lesson on the curves. But today, the main takeaway is when we're solving these quadratics, I want you to understand that what you're actually finding is where the curve cuts the x-axis. If you can be clear on that, when you solve quadratics, you'll actually have an understanding of what you're doing. You won't just be doing a method, you'll actually be thinking to yourself, oh, that's where that curve cuts the x and the y-axis, or the x-axis, sorry. Okay, so how do we do it? How do we use factorising to solve a quadratic to find out these solutions or roots? Well, if we take example 1, which says solve x squared equals 0, and we know, and what I've done here is I've mapped these two equations with these two curves. That's this curve here, and we already know the answer to this. So it's interesting to see, how do we get the answer that we already know? The answer to this would be x equals 0, hopefully, because we can see that it cuts or sits on the x-axis at 0. Well, if we wanted to solve that, that's quite a simple equation. Usually throw students off, but what number do we square and get 0? What number do you times by itself and get 0? Well, obviously, the only number in the world that you can square and get 0 would be 0. So we could say here that x must be 0 because 0 squared is 0. And we can see clearly that this curve, x squared, cuts or sits on the x-axis at the point 0. So that would be that one done, and we've proved that. Where things get tricky and why factorising is so important is if I tried to solve example 2, which is the second curve, x squared plus 4x plus 3 equals 0, if I tried to solve it as if you would solving a normal equation, we would, I don't know, maybe you would, and this is wrong, please don't copy this, you might minus the 3 from both sides to get minus 3, and then x squared plus 4x equals 0, and then you might take away the 4x. But the problem here is we get minus 3 minus 4x. What would we end up with? We've ended up with x squared, but there's another x over there. And if the goal of this is to find out what x is, we can't have two x's knocking around. We only need one x. We need to know the value of one x. So the reason why factorising is so important here is it allows us to find the values of x that satisfy. Okay, so when you see a quadratic that is equal to 0, they are asking you to solve it. Yeah? And what is that actually getting you to find? It's asking you to find the solutions or roots, which is where the curve cuts the x-axis. So hopefully if we do this second example correctly, we would see that x should be minus 3 and x should be minus 1. So let's see how that's done. Example 2. We've just shown that we can't solve this by normal linear equation methods where we would just take stuff away from both sides or divide or whatever it may be. We have to use factorising. So as I stated before, you need to know how to factorise to be able to do this part of the lesson where we solve. So I'm assuming we know how to factorise, and if you don't, go back. I'll run through it very quickly, but I won't be dwelling on any certain points. Remember, when we solve a quadratic, we need two numbers that multiply to make 3 and add together to make 4. So multiply together to make C, add together to make B. Remember, we list the factors of 3. What makes 3? 1 and 3. Or two negatives, minus 1 times minus 3 would also make 3. Which one of those add to make 4? Well, clearly it's the top one. So I factorised it. Hopefully from there we can see that x is plus 1 and x would be plus 3. And that is equal to 0. So we factorised. We have factorised, and we now have got a factorised quadratic that we can solve. Because what does this say? It says this bracket multiplied, remember when they're touching it means multiplied. If you expanded this, you'd have to multiply it out. Multiplied by this bracket is equal to 0. Now, if you think logically, if you multiply anything, how do we get 0? Well, one of them has to be 0. So hopefully you agree that if this was 0, I could multiply this by anything and I would always get 0. And if this was any number and I multiplied it by 0, I would get 0. So what we've just talked about there is one of those brackets has to be 0 to make this true. We need to times something by 0 to get 0, or the other bracket needs to be 0 to get 0. It's the only way we can get 0. So what does that mean? That means that this bracket must equal 0, and this bracket must equal 0. Well, how do we do that? Well, what would x be to get 0? Something plus 1 is 0. Well, the easiest way to do this is to just write that out. X plus 1 equals 0. And this one is x plus 3 equals 0. How do I solve that? Well, we would just minus 1 from both sides. And you could probably do that in your head. So x equals minus 1, because 0 take away 1 is minus 1. And this one, if I minus 3 to get x on its own, I would get x equals minus 3. So my two answers that I get, my two solutions, my two roots would be, we could say therefore, x equals minus 1 or x equals minus 3. Because they are the two numbers that make this bracket 0 and this one makes this bracket 0. which would mean 0 times anything is 0, and anything times 0 is 0. So it makes perfect sense. A lot of your teachers might say, just flip the signs. Yeah. When you get this x plus 1, the answer is the opposite sign, which is minus 1, which works. And this is x plus 3. Flip the signs. This would be minus 3, which works. But the reason it works is because we need it to be 0. It's really important that it's 0. So you just make it equal to 0 and solve. And essentially all you're doing is ending up taking that 1 over the other side, so it becomes negative, and over here we took the 3 to the other side and that became negative. But does that map to our assumption given the graph? We said here x is minus 1 or x is minus 3. Well, where are the roots or solutions for this? Minus 1 and minus 3 on the x-axis. Perfect. We've done it. Absolutely brilliant. So what have we learned there? You factorize. You have to factorize because a quadratic cannot be solved without factorizing or doing some other things that we'll talk about in future lessons. But factorizing is usually your go-to, and that allows you to make each bracket equal to 0 and solve it. So I've written that as remember me here. Remember, once you've factorized, you need to solve this bracket equal to 0, and then you need to solve this bracket equal to 0 because of what we said. To get 0, one of them must be 0. So our 2 bits of information that we need to really understand going into solving quadratics is how do we factorize and can we solve basic equations? And if you can do those 2 things, this topic is easy. And then linking it to, this is where the curve cuts the x-axis. These are the solutions, these are the roots. They are the common names used for them. So if we go into example 3, we want to solve. So we want to find where does this curve cut the x-axis. And we can see that it cuts at 2 points. We usually get 2 answers because the symmetry of the curve means that it's going to, if it goes down one side, it's going to come back up and cut at another place. And so we're trying to find where does this curve, when it's equal to 0, cut the x-axis. That's what this is asking us. Always make that link. Well, it's a quadratic. We're going to have to factorize it. So we're going to need 2 brackets. And we're going to have those equal to 0. So how do we factorize? Well, we need 2 numbers that multiply to make c, which is minus 8, and add together to make b, which is plus 2. So we're going to list our factors of minus 8 off to the side. How do we make a negative? Again, this is all, I've gone through all of this in our factorizing quadratics lesson. Okay. We need a positive and a negative. We need a mixture because it's a negative. Well, minus 1 and 8, or 1 and minus 8, minus 2 and 4, or 2 and minus 4, because you need those opposite and alternate versions. Which one of those, if any, make 2? We need plus 2. Well, definitely not the first 2. Minus 2, add 4, that would give us plus 2. If we started at minus 2 and added 4, that would give us plus 2, so we found it. So in our bracket, we need an x and an x, because remember, that's how we get x squared. And then a minus 2 and a plus 4. So from there, we have factorized. Remember, we need to solve each one to be 0, because this needs to equal 0, which means one of these brackets need to be 0 to make that true. So if we do that, if we solve x minus 2 equals 0, the first thing we'd do is just take the minus 2 over to the other side by adding it. We'd add 2 to both sides. So we'd get x equals 2. That's one of our solutions. Okay, so one of our solutions is x equals 2. The other solution would be when x plus 4 equals 0. Well, how do we get x on its own? We would take 4 away from both sides to get x equals minus 4, because 0 take away 4 is minus 4. So our 2 solutions, what does that mean? You should always think to yourself, what does that mean? I've got 2 answers for x. It means that those 2 values for x, 2 and minus 4, is where this curve cuts the x-axis. And I said right at the beginning, the c on the end is where it cuts the y-axis. So I could even just make a little sketch of this curve. I know, just from the information we've discussed today, I know that this curve will cut the x-axis at minus 4 and 2. So if we pretended and did a sketch, it's not accurate. Let's say that this is minus 4 and this is 2 on the x. And we know it cuts the y at c, which is minus 8. just going to cut the y down on the minus y-axis at -8. So let's just pretend that's -8. It's not to scale. So our curve would look something like this. We have found that the curve cuts these 2 points here on the x, and the y has come from the c, which is the -8. So just from having that understanding that when you solve a quadratic, you're finding where it cuts the x-axis, allows you to be able to envision what this curve looks like, and even sketch it if you need to, like what I've just done there. Okay. But the answer to this question would just be x is -2. So if you want to finish that off, you could say therefore x equals 2 or x equals -4. Those would be your two answers for this question. What I've done here with the curve is just me going off on a tangent and really trying to link it back to what I discussed at the start. Example 4, and this is why you need to know those key words, solutions, roots, because they can ask you questions like this. Find the solutions of a squared minus 8a plus 15 equals 0. Well, it's a quadratic. It's going to be the same. They can use other letters other than x. It doesn't have to always be x. But if I want the solutions, I need to find where the curve cuts that x-axis, or in this case the a-axis, because they're calling it a, by factorising. So we will factorise. We know that we're going to need two brackets equal to 0, because that's how we solve. We need two numbers that multiply together to make c, which is plus 15. And straight away you should be thinking in your head, 15 is where this curve is going to cut the y-axis. And they need to add to make -8. So again, same method. We will write out 15. We will list the factors. Now, how do you make a positive? Two negatives or two positives? You can be quite clever here. If you know about factorising, which you should at this point, I need a minus number to add, and I need a plus number to multiply. That means I'm probably going to need two negatives, and I can ignore all my positive versions. So if we stick with negatives, we could say -3 and -5 would multiply to make 15. But what does it add to make? -3 take away 5 would add to make -8, which is perfect. So I can see straight away that my bracket needs to be a -3 and a -5. Well, from there, to solve this, remember each bracket needs to equal 0. So a -3 equals 0 and a -5 needs to equal 0. Now, again, your teacher might just tell you to flip the signs, but this is why. This is why they tell you to flip the signs, because it works. We're going to add 5 to both sides if we were solving this, which would give us a equals +5. And over here, we would add 3 to both sides to get a on its own, which would be a equals 0, add 3 is 3. So our two solutions are here. We found them. We could say, therefore, that's what those 3 dots mean. Therefore, a is 3 or a is 5. Why do we have two solutions for this? Well, it means that this curve cuts the x-axis at 3 and at 5 and crosses the y-axis at 15. So the curve looks something like that. Okay. You usually end up with two values for your solution because it cuts the curve at two places. Example 5, x squared minus 9 equals 0. Now, there's two ways we can do this. This is the difference of two squares. If I want to factorize it, you should know the difference of two squares is this. I've got a squared minus the difference of another square number. 9 is a square number, and you should know that this is the difference of two squares. So we'll just write that, the difference, and that's a special type of quadratic, difference of two squares, where, and I spoke about this in the last factorizing lesson, we know that it's x and x, and how do we make 9? Or minus 9, it would be plus 3 and minus 3. And what that would do is, there's no b, is there? There's no bx. A difference of two squares is special because a plus 3 and a minus 3, when expanded, cancels out. You got plus 3x minus 3x. You would get minus 9 and x squared. Those three x's cancel, so we're just left with x squared minus 9. Now, interestingly here, both of these brackets need to equal 0, remember, to solve. So we need to say x plus 3 equals 0, which would, and this is why teachers tell you to flip the signs, because it's the same every time. It's easy. You have to minus 3 here, so we'd get minus 3 as our answer. Here, we'd have to add 3, so we'd get positive 3 as our answer. So the two answers for this, the two solutions, the two roots where it cuts the x-axis, is going to be at x equals minus 3 or x equals plus 3. Okay. The other way we could have solved this, which is some basic linear solving, is this. Or another alternative method would be, how would we solve this as if it was a linear equation? We would add 9 to both sides, okay, which would give us x squared equals 9. Then we would square root both sides. Now, the important part here is, what is the square root of 9? 3. However, when you take the square root of something, you would get the positive and the negative version of that answer, because negative 3 squared would be negative 3 times negative 3, which is 9. So that works. And obviously 3 squared is 3 times 3, which is 9. So when you take the square root of something, it's really important that you remember that you should get the positive and negative versions of the answer. So the square root of 9 is plus or minus 3, which maps nicely into that, plus or minus 3. Same answer. This way, potentially a little bit quicker if you've forgotten the difference of two squares method. Okay, so that now takes us on to the more involved factorising, where, remember, if you have a as greater than 1, which in this case it is 2, there's a little bit more involved to factorising that. So, example 6, give the roots. What does that mean? You should be thinking, linking that keyword, roots, to where the curve cuts the solutions of the x-axis. That's what we're looking for. And the method to find that is to factorise. So we need to solve this equal to 0. And the only difference here is we've got a 2x squared rather than just an x squared. So remember, to do that method, you take a and you take c and you multiply them together. So the first step is going to be multiplying a and c together. 2 times positive 3 is 6. We list the factors of 6. And again, go back and watch Factorising Quadratics 2 if this is confusing or you don't understand this, because I'm assuming you know it. Listing the factors of 6, 1 and 6, 2 and 3. What am I trying to make? I'm trying to make b, which is plus 7. Well, 1 and 6 makes 7. Where we go from there is we rewrite 2x squared, and we're going to replace 7x with 1 and 6. Now, it doesn't matter which way we do this, because 6 goes nicely with 3 and with 2. So we could say plus 1x plus 6x plus 3 on the end. So if I colour coordinate this, all I've done, I've left a and c alone, and I've just changed our b, and I've pulled it apart. 7x is still 1x. If I simplify 1x and 6x, I still get 7x. So I'm just pulling this apart. From there, we split it down the middle, remember, and we factorise each side. Okay, so if I factorise this left side, what comes out of 2x squared plus 1x? Well, no numbers, the biggest number is 1, and we could take an x out. So if I take an x out, that would leave me with 2x plus 1 inside the bracket, because x times 2x is 2x squared, x times 1 is 1x. The trick here is, we know, hopefully, that we're going to get the same thing in this bracket. So we could just copy and paste that in. We could say, look, that's going to be 2x plus 1 and work backwards. What would have to be here to multiply 2x by to get 6x, and to multiply 1 by to get 3? Well, hopefully you can see that it would be 3. From this point, we are done. We have factorised. We could say that our two brackets that have been factorised would be 2x plus 1 is one of them, and the leftovers, okay, the bits left over the x and the 3 is what goes in the other bracket. So x plus 3. And we know this is equal to 0. It's nice and easy now. Once you've got it factorised, remember, one of these brackets needs to be equal to 0, as does the other. So we need to solve both of these equal to 0. And this is why it's nice knowing this method, because now what you can see on this one is we can't just flip the sign on this. This one we can, because it's an easy solve. Okay, if we start with x plus 3 equals 0, if I solve that, I'm just going to minus the 3 from both sides and get x equals minus 3. So that would be that answer. Done. Okay. The other one though, what's the first step to solving that equation? We have to take away 1 from both sides, which would give me 2x equals minus 1. Then I need to divide by 2 to get x on its own. So x equals minus a half. So that one, you definitely need to understand that you have to make it equal to 0 and solve. So what are my two solutions? Well, I can say that my roots, my solutions, where it crosses the x-axis is going to be at x equals minus a half, which is fine, you're allowed that, or x equals minus 3. It cuts the x-axis at those 2 points. And that'll be that question done. We've got 2 left, and this is going to tie heavily onto our understanding now. Example 7. Find the solutions, so where it cuts the x-axis, where the curve cuts the x-axis, that's what we're looking for, of x squared plus 8x plus 10 equals 3. Now, that's a bit of an issue because the whole lesson we've been talking about, to solve quadratics, they need to equal 0. Okay, y needs to be 0 on the x to solve it, so it needs to equal 0. First problem here is this one equals 3. So let's just make a note here. This needs to equal 0. Well, how are we going to get rid of this 3? How are we going to move it over here? That's some basic linear stuff. Let's just minus 3 from both sides. So if we minus 3 from both sides, we're going to get x squared plus 8x. Well, what's 10 minus 3? Plus 7 equals 0. So we're going to minus 3 from both sides. That's your note. Okay, now it's okay. Now we've got a nice quadratic that is equal to 0 that we can solve to give its solutions, find its solutions. Well, we need 2 numbers that multiply to make 7 and add to make 8. Let's list the factors of 7. Prime number, 1 and 7. Oh look, what's 1 add 7? 8, so that works. So our 2 brackets will be x plus 1 and x plus 7 equals 0. Now remember, we need to solve both of these equal to 0. Well, at this point, you can think of this as just flipping the signs, because we know, don't we, if we make these equal to 0, x plus 1 equals 0, well, I'll take the 1 over the other side, so x is minus 1 is one of my answers, or if I make this one equal to 0, x plus 7 equal to 0, I'm going to get x equals minus 7, because I would take away the 7. So our 2 answers for this question are x equals minus 1 and x equals minus 7. And always ask yourself, what is that telling me? That's telling me that my curve, my quadratic curve, is going to cut the x-axis at minus 7, which we could say is here, or minus 1, which let's just pretend is there. And look, it cuts the c at 7, so up here at 7. That makes perfect sense. Come down here, up here, back through there. That's what that curve looks like. That is what we are finding, and it's really important that you link that. That you don't just know the method, that you actually understand what it is you're finding. So that takes us nicely on to example 8, which is very, very similar. We will need to solve, aka find where it cuts the x-axis of x squared plus 6x plus 15 equals 3 minus 7x. Now the problem there again is it needs to equal 0. So how do we make this equal 0? Well, we need to minus the 3 and we need to plus the 7x. Yeah. How do we move this? We do the opposite, take it away. How do we move a minus 7x? We do the opposite, we add 7x. And we need to do that to both sides. We need to minus 3 and add 7x to this side. Well, let's do that. We've got x squared plus 6x, but we need to add 7x to it. So that would give us x squared, 6x add 7x would be 13x. And then we've got 15, but remember we need to minus 3 from it, so that would be plus 12. And now that equals 0. Now we have a nice quadratic that we can solve. How do we solve this? Well, again, we need two numbers. They're multiplied to give us 12, the c, and add to give us b, which is 13. Same method as always. We're going to list out the factors of 12. What makes 12? 1 and 12. Oh, look, that works, doesn't it? Straight away, we found it instantly. 1 add 12 is 13. So that would be my two factors. So my brackets will say, look, we've got x plus 1 and x plus 12 equals 0, because we're solving it for when it equals 0. Therefore, this bracket must equal 0. So x plus 1 needs to equal 0. Remember, why? Because 0 times anything would give us 0, so that works. And we need to make this one equal to 0, x plus 12 equal to 0. Because if this was 0, this could be whatever it wants, and we'd always get 0, because anything times 0 is 0. How do we solve that? Well, this one we're going to minus the 1, so we're going to get minus 1. And this one we're going to add the 12, minus the 12, so we're going to get minus 12. So we could say, therefore, our solutions, where it cuts the x-axis, is at minus 1 or x equals minus 12. And that would be us complete. So, the takeaways there, if we start from the back going forward, the first thing is, if it doesn't equal 0, make it equal 0. It needs to be equal to 0 to solve. A quadratic must equal 0 to solve it, to find the solutions or the roots. The solutions or the roots just mean, where does that curve cut the x and the y-axis? Usually you get two answers. The reason for that is we've seen a curve is symmetrical and generally cuts at 2 points. Okay, the difference of two squares, getting used to that is really important, but essentially all we're doing is factorizing, which hopefully you can already do, and then we're just making each bracket equal to 0 and solving. But the biggest takeaway of this is what you are actually finding. I want you to take this away. When I factorize and solve a quadratic, I am finding where the curve cuts the x-axis. And we call this the solutions or the roots. If you can do the method, that's brilliant. But more importantly, if you can understand what it is you're doing, that's going to be the key to really starting to understand quadratic graphs and how they work. Okay. Thank you for joining in. Hopefully you learned something, and I will see you in the next one.